My name is Ella Dougherty and my material is tantalum. There are many materials that are used every day by multitudes of people all over the world. A lot of times people do not know what some of the crucial items that they use are actually composed of. Although not very well known, tantalum makes it possible for items that are a large part of society to be used. Tantalum was first reported as a metal in 1802 in Sweden. When the minerals that surrounded the tantalum where it was discovered were analyzed, it was found that tantalum was identical to niobium. Niobium was found only a year before. This created confusion over the identification between the two, and these two elements often occurred together. Because they were usually found together, it was hard to separate the two elements by modes that were available at the time. In 1846, after Heinrich Rose was able to separate the two, it was concluded that niobium and tantalum are two different elements. The samples of tantalum were still difficult to separate completely, so pure tantalum wasn't produced until 1903. Tantalum is an element with atomic symbol Ta and atomic number 73. It is a rare element that is hard blue-gray and a lustrous material. One of the most famous and important characteristics about tantalum is that it is highly corrosion resistant. Tantalum has some very important mechanical properties. The tensile strength is 900 megapascals. It has a Poisson's ratio of 0.35, a modulus of elasticity of 186 gigapascals, a shear modulus of 69 gigapascals, a density of 16.65 grams per centimeter cubed, an ultimate tensile strength of 285 megapascals, and a yield strength of 170 megapascals. The ductility is also extremely high because it has the fourth highest melting point of all of the metals on the periodic table. The primary bonding of tantalum is metallic bonding. The melting temperature is 3017 degrees Celsius due to its strong bonds. The crystal structure is body-centered cubic, BCC, with an atomic packing factor of 0.68. There are 2 atoms per unit cell, and the atoms have a radius of 145 picometers, and the length of the unit cell is 330.13 picometers. The main use of tantalum is for electronic components, specifically tantalum capacitors. When it is mixed with other metals to be different alloys, it can be used to make tools for metalworking, in superalloys for jet engine components, and in the chemical industry while working with corrosive chemicals. A large industrial impact of tantalum is that under temperatures of 150 degrees Celsius, it is almost completely immune to any attacks from chemicals and corrosion resistant from an oxide film that covers its surface. Because it is so compatible with the body, tantalum can be used in prosthetics, dental and surgical implants, and clips. Tantalum is also a very expensive material at $162 per kilogram, but it is still one of the most sought after materials in the technology industry because of its use for capacitors. Tantalum is growing in importance all over the world. With an increase of technology usage and development, the need for tantalum has also increased. This means that there has been a necessary rise in the mining of tantalum. Tantalum is usually found and mined from tantalite. In nature, tantalum isn't usually found in water from mining. This is because tantalum oxide is not very soluble in water. There hasn't been much research to measure the amount of tantalum found in soil, so there is a large range from 0.1 to 3 parts per million of tantalum found. A regular amount of tantalum found in plants is usually very low, so the vegetation isn't very affected by it. So luckily the environment isn't substantially harmed from the mining. The main areas for mining tantalum are Rwanda, Australia, Thailand, Congo, Brazil, Portugal, and Canada, and the worldwide demand for tantalum is around 2,300 tons. 60% of the world's tantalum comes from Rwanda and the Congo, which are areas that are known for their problems associated with conflict minerals. The top conflict minerals are tungsten, tin, and tantalum, which are all used in the technology industry. There have been issues in the Congo over the mining practices used there. There have been routes taken to attempt to halt the purchasing of tantalum that was produced unethically in the Congo, but those trying to fix these problems have had to face many difficulties in doing so. The attempts that have been taken have seen slow positive responses, but they are continuing their efforts to make tantalum mining as ethical and honest as possible. The people of the Congo face devastating effects of tantalum mining. They are raped and murdered by the rebels that control their land, so they aren't reaping the benefits of the vast industry there, but are instead in fear of their lives. These rebels have been seizing tantalum mines and taking the profits into their own pockets, which further fuels their power, all while the government turns a blind eye to the suffering people of the Congo. There have also been accusations of child labor in the mines, with ridiculously dangerous conditions for children. After the tantalum from the rebels' mines is extracted, they smuggle it out into the neighboring Rwanda and sell and ship the tantalum to smelters in East Asia and China. There is now the Dodd-Frank reform that states that companies that are registered with the United States Securities and Exchange Commission are required to inform them if they are receiving tantalum or other conflict minerals from the Congo, and if it came from mines that are at the sites of conflict. For a mine to be considered conflict-free, there can be no children or pregnant workers in a mine that is not owned by or run by violent rebel leaders and pays their workers. There were other international attempts to continue the improvement of the ethics in tantalum mining that were started from the Dodd-Frank reform. The conflict-free smelter program makes sure that smelters are melting down reliably sourced tantalum. Smelters are what are also control the production of tantalum because there is only a certain amount of them due to these new restrictions that have put in place. There has been research in Eastern Congo that have shown that the Dodd-Frank reform has been successful so far. The health effects of tantalum aren't extreme, but it can be harmful if it is inhaled, ingested, or absorbed by the skin. Tantalum can also irritate eyes, skin, mucous membranes, and the upper respiratory tract. Workers that are exposed have not reported any negative health effects, so there haven't been any extreme measures taken to prevent any dangerous exposure. When tantalum is being cut, ground, or melted, fumes or dust with high concentrations can be produced, so workers need to be wearing protective gloves, respirators, safety glasses, and various forms of protective wear. Different compounds of tantalum can be very explosive when they react with other compounds, even though the tantalum is very stable. Tantalum needs to be extracted from the mines and refined in a refinery. This is usually done by treating the ores from the mines with hydrofluoric acid and sulfuric acid at very high temperatures. Due to this treatment, the tantalum and its impurities dissolve into complex fluorides, and the other elements are also present here. The filtration and further processing of the tantalum slurry ends with a solution of tantalum that is highly purified. After the solution is present, it is usually converted to be potassium tantalum fluoride or tantalum oxide. Another method involves blending coke with crushed concentrate and putting this through a chlorination stage that separates the elements that aren't tantalum. The resulting gas is chlorinated to produce TaCl5, which is then fractionally distilled, and the tantalum fluoride produces the oxide when it is reacted with ammonium hydroxide. Tantalum metal powder is usually made when the sodium reduction of potassium tantalum fluoride is put into high temperature molten salt systems. A large portion of tantalum can be recycled. Under optimal conditions, 93.56% of tantalum can be recycled from the previous material. However, only about 1% of the world's tantalum is recycled. This is due to people simply not recycling the material, as well as limited facilities that have the capabilities to do this, and the knowledge of the public that tantalum can be recycled. I was unable to find the amounts of water and carbon dioxide produced from the production of tantalum. I think that this is because the recycling of tantalum isn't abundant or widely used yet. Overall, tantalum is a very interesting material that has extremely useful properties. Even though tantalum isn't very well known, it is in so many more products than we know, even those that we use frequently. We live in a world that is dominated by technology. The importance of tantalum will only grow, which will lead to even more discoveries of what it is capable of.